Hello everyone, this is my second lecture on adsorption. Today we shall discuss about the adsorption isotherms. That means the extent of adsorption as a function of pressure or concentration, along with out of the three adsorption isotherms, Freundlich, Langmuir and BET, we shall discuss about the Freundlich isotherm today. Before that, we have to know the types of adsorption. There are two types of adsorption. One is physical adsorption, another is chemical adsorption. Due to its property or type of interaction, physical adsorption is also known as the van der Waals adsorption. On the other hand, chemical adsorption is also known as the activated adsorption. Or in short, physical adsorption is called physisorption and chemical adsorption is called chemisorption. Now, what are the definitions? What about physical adsorption and what about chemical adsorption? All the gas molecules have the tendency to be adsorbed on solid surface by weak van der Waals attraction force. This is known as physical adsorption. That means on a solid surface, gas molecules, all the gas molecules have tendency to be adsorbed. So this adsorption actually is nothing but due to the weak van der Waals attraction force, and this is simply a physical adsorption. But if some chemical bond such as covalent bond is formed, then this is no more a physical adsorption, this becomes a chemical adsorption. So when the valence forces come into play, that means covalent bond is formed to hold the molecules on the surface of the adsorbent. This is known as chemical adsorption. So there are lots of features other than their definitions in physical adsorption or in chemical adsorption. So we have to distinguish them. So before differentiating them, we have to know about one more term which is known as the enthalpy of adsorption. So what is enthalpy of adsorption? Actually, after adsorption, the surface energy is released. Why the surface energy is released? Because the surface energy is actually in the form of residual energy. Residual means the intermolecular attraction forces are all utilized in holding the molecules within the bulk of the solid or in the liquid. But on the surface, there is some residual force of attraction. That means some bare forces which can be further utilized. So when the adsorbate molecules come and get attached on them, then this residual energy is released, and this energy is evolved in the form of heat energy. So definitely adsorption is essentially an exothermic process. Energy is always released. Delta H is always negative. So during adsorption, there is a decrease in the residual attractive forces present on the surface of the adsorbent, leading to decrease in the surface energy of the adsorbent, which is evolved as heat. Thus the enthalpy of adsorption is negative, and thereby adsorption is essentially an exothermic process. Now in this context, I must say one more thing, that when we say that the enthalpy of adsorption is high, that means high amount of energy is released. So the negative sign can be neglected by using a modulus sign. Now move on to the differences between the physical adsorption and chemical adsorption. Physical adsorption is a low enthalpy process where only up to 20 kilojoule of energy, kilojoule per mole energy is released. Per mole means the per 1 mole adsorbate. Suppose hydrogen gas is being adsorbed on platinum. So for 1 mole of hydrogen gas to be attached on the surface of platinum, minus 20 kilojoule up to minus 20 kilojoule of energy may be released. But if some chemical adsorption takes place, then this range gets higher, up to 10 times than that of the physical adsorptions. It may be 80 kilojoule per mole to 200 kilojoule per mole. So this much energy may be released per adsorption of 1 mole of the adsorbate molecules. Now, the opposite process of adsorption is desorption. When molecules are attached, this is adsorption. When the molecules are detached, this is desorption. And these two taking place at different rates. When adsorption has greater rate, higher rate than desorption, then adsorption takes place. When desorption has higher rate, then desorption takes place. When both the rates become equal, then equilibrium takes place. Now, the equilibrium in case of physical adsorption is only reversible. That means both adsorption and desorption are possible in case of physical adsorption. But in case of chemical adsorption, once adsorption takes place, no desorption is possible. So it's a one-way equilibrium. That means this equilibrium is irreversible. Only adsorption takes place, no desorption is possible. And not only that, this equilibrium is established very slowly, whereas in case of physical adsorption, this equilibrium is established very rapidly. So this is a reversible equilibrium, this is an irreversible equilibrium. Number 3, in case of physical adsorption, it is a low temperature phenomena, and for chemisorption, it is a high temperature phenomena. And in case of physical adsorption, it is very effective below the boiling point of the adsorbate. Number 4, in case of physical adsorption, activation energy is not required. But in case of chemical adsorption, activation energy may be required. Physical adsorption is a multi-layer phenomena. That means on the surface of the adsorbent, more than one surface of the adsorbate molecules may be formed, and then the equilibrium is established. On the other hand, in case of chemical adsorption, it's a monolayer or unilayer phenomenon. That means once a single layer is formed, no other molecule can attach on the surface of the single layer, first layer. The function of the adsorbate is main here. On the other hand, function of both are important in case of chemical adsorption. That means in case of physical adsorption, there is no function of the adsorbent, while in case of chemical adsorption, both function of both adsorbate and adsorbent are important. Finally, the extent of adsorption increases with increasing pressure. This is very important, and here it decreases with increasing pressure. Okay, so here the extent of adsorption is directly proportional to pressure, while here the extent of absorption is inversely proportional to pressure. Now move on to the main topic of this subject, the adsorption isotherms. So what is the adsorption isotherm? Actually, isotherm terms is used because this phenomenon is taking place at constant temperature. So at constant temperature, if the extent of adsorption is plotted against changing concentration or pressure of the adsorbates, then the plot obtained is called adsorption isotherm. So in case of gases or solid surfaces, the following 5 types of isotherms have been observed. What are these? Here type 1, type 2, type 3, type 4 and type 5. Here rapidly increases and then flattens. That means there is no increase. Here rapid increase, a little slow, and then again rapid increase. Here from the very beginning, rapid increase, increase and increase. Here rapid increase, then slowing down, again rapid increase, then again slowing down. Here rapid increase and then slowing down. And all these pressures are actually the limiting pressure. That means after this pressure there is no appreciable change in the absorption amount, particularly this one. This will be observed in our Freundlich absorption isotherm. Let's see. In the Freundlich absorption isotherm, X by M is the extent of adsorption. X is the amount of adsorbed gas molecules, while M is the amount of the adsorbent. Okay, and P is the pressure of the adsorbate substance. Well, K and N are some constants. So if X by M, that is extent of adsorption, is plotted against P, then this type of graph is obtained. X by M in the y-axis, P in the x-axis, and T is constant. Then this rapid increase, then flattening of the curve takes place. So this curve is obtained. Now if you take log of both sides of this equation, then it will become log k plus n log b. Well, now you can get a straight line with slope log k and with slope n and intercept log k. So what is the type of the graph? This is the type of the graph. So this way you can determine the value of the two constants. So that's all about Freundlich absorption isotherm. Next, in our next class, we shall discuss about Langmuir adjustment isotherm and the BET adjustment isotherm. So that's all for today. Thank you.